Okay, last time we were talking about linked list, and I gave you an overview of what a linked list is. Just to give you a brief recap of what we did last time. Linked list is a data structure where the items are placed at different locations. For example, each node of the linked list has two portions. First portion is the data which contains the item to be stored, for example 7 here. The next portion basically contains the address of the next node which occurs after a particular node. For example, this node is the first node. Let's assume that its address is 111, and this is another node. Let's assume its address is 333. So each cell has two portions. One is the data portion, other one is the address portion. So here in this address portion we will have 333 as our address, and then in the next node we can have another data item, let's say 88, and since we have no other node after this particular node, now this node's next cell will have null value, right? And for the complete linked list we have a particular pointer for the overall complete linked list, and this pointer is usually called head node, head pointer, and it contains the address of the first node. It always contains address of the first node, right? So last time I gave you a conceptual view of the linked list without worrying about the actual details, how will we be implementing it. But in this particular lecture we will be going through the implementation of the linked list and how we code it in C++, right? So these slides are already uploaded at the CMS, Campus Management System, from where you can download. So I'm not going into the detail of each and every component. Instead I am going to the crux of the matter. For example, these simulations we covered in the last lecture already. So let us go to the implementation directly. Right. Now, if you see here, we have created a class. Here, if you see, the name of the class is int list. You can name it simply list as well, but since this class, in this class, the nodes of the linked list which we are going to create, the data field of these nodes will contain integer numbers. So that is why it is named as int list, right? Maybe you would like to create nodes of the linked list where the data portion of the node contains, let's say, character. Then in that particular case you can replace this int with char list or character list, but this name is just to make sure that if somebody reads it after a long time, he or she perceives it, that what does it mean, right? Then now, as I've told you earlier, that whenever you study somebody else's code, and whenever you are studying their class object-oriented code, the first thing you need to read is the variables which are in the class. Now, if you see here, in this particular class, the variables, or we call them data members as well. And now if you see, these are the data members, right? Now the first data member is basically a structure, right? This is a structure, struct node, and within this node we have two values. The first value is of an integer type called the data, and the next value is a pointer of type node. So this node, this pointer is of the structure node type itself. So since this pointer, okay, let me draw it to you. For example, what will happen here, this actually represents a structure which has two portions. One is the data and the other one is the next pointer, right? Now this particular pointer will be pointing to another node, complete node, right? It will be pointing to this complete node, right? So since this thing is pointing to a thing of its own type, so this is called a self-referential data structure, right? Now because this node is pointing to another node which is of type node, right? For example, if you see if a person is pointing, let's say, to another person, right? So both of them are humans, right? So this is called self-referential. But if a person is let's say pointing to let's say box, I was thinking about drawing a cow, but that will be challenging here. Even this box is difficult to make. But if this person is pointing towards this box, so it's not self-referential, right? But this one is self-referential because one human is pointing towards another human, right? So that is why we call linked list a self-referential data structure where each node points to another node, right? So coming back to coming back to what I was saying, that this first variable in the class is a structure, right? With which this name of this structure is node, right? And each node has a data field and the next pointer, right? Then in the class, now this is our first variable in the class, and this one is the second variable in the class. And this variable, if you see, this name of this variable is list head pointer, right? And it is of type node, right? So this will be a pointer which will contain address of a particular node. Since we know that it will always contain the address of the first node of the linked list, so that is why we have named it list head pointer, right? So these are two variables variables of the class. Where members of the data members of the class, you can call them variables of the class, right? And then we have a number of functions. Now I'm not going to read out all these functions because I'm going to explain them one by one using a dry run option. But before going to the explanation, the first thing, which is the simpler one, let us see the constructor of this class. The class name is the class name is intlist, and the name of the constructor is of course intlist as well. And within the constructor, what we do, we simply initialize this head pointer as null, right? Because if you see, when for the first time we create an instance of this class, let's suppose we are in main, and in main we write int list, let's say we call x, right? Now this x variable represents a linked list. It represents a linked list, but when we have declared this linked list for the first time, this list does not exist, right? Because this list does not exist, the head of the list also does not exist, right? Because we have just declared it. And when we declare an instance of this list class, automatically the first thing which is being called is the constructor of this class. And since the list is not created and head is not created, so that is why initially this head pointer is initialized to null, right? So this is that is why it is initialized to null. And now the first function in the class is the add node at head function. It receives a variable val of type int. And now we will go to the definition of this function. Now what I do, I simply copy this piece of code from here. Let me paste it onto the drawing board. It's a free plan. Okay, let us try to use it anyway. And okay, so far we have gone through the variables of the class and the constructor of the class. Now I am going through the add node at head function of the class, right? Now I'm pasting this code here, and okay, and I'll be explaining it I'll be trying to explain it using simulation. Now if you see here, okay, sorry, if you see here, Now when the instance of the class is created, we have a pointer named head, which is initialized to null, right? Now this head pointer is initialized to null. Okay, let me zoom it in. This head pointer is initialized to null, and then we call the this add node at a head function, and let's assume that we we pass a value of, let's say, 7 to this function, right? Okay, now what will happen within this function? The first line says that create a new pointer, node type pointer, new PTR, and through the new operator a node is created. Now if you recall, I told you that this new operator does three things, right? First of all, it allocates memory for the object, right? First of all, it will create memory for this node type object, so it will create a memory for this object. Secondly, what it does is that if it will return the address, of this created memory. So since it will be returning the address of a node type thing, that is why we have created a node PTR, so that a pointer of node type, so that the address of this particular thing will be stored in new PTR new, right? And the third thing what this new operator does is that if the item for which it has created the memory or allocated the memory, if that item has a constructor, it will be calling the constructor of that particular item, right? Now if you see here this node, if you see here, this node is of type struct, right? So this structure does not have any constructor, so only the first two things will be happening. Now let me show how that works. For example, this new node will be created, and okay, and now this new node will be created, and let us call it PTR new, right? Now this is PTR new, and let's assume that its address is 333. Let's assume it's now this thing will be created, and its address, this 333 address, this 333 address will be stored in this PTR new, right? Now this line does that much. This line does that much. So this node is created. Then in the next line, what does this next line do? It says that PTR new, this PTR new has two fields, we know. If you see here yes, if you see here, this node has two fields, data and next pointer field, right? Now this is the data field, and this is the next pointer field, right? It says that okay, this PTR new has the data field, put in that data field the value. If you recall, I told you that the value we assume is 7, right? So here a value of 7 will be placed in the data field, and what it says that okay, in the next line, PTR new next, this in this particular field of this node, place whatever is available in the head PTR, right? If you see here in head PTR, what do we have? We have null, right? So here we will be having null, right? We have created the first node. So far what we have done, we have created a node, we have placed the value in the data, we have placed the pointer in the next field, since it's the only node, the first node and the only node in the linked list. So it does not have any next node, so that is why in the next field we have placed null. Basically we have copied this null from head, but this node is not part of the linked list, because if you see this head is null, it means that it is a standalone node, so we need to connect it to the head. So if you see here in the last line, we say okay, list head is equal to new PTR, right? If you see, this new PTR has the address what? This has address 333. So what will we be doing? Okay, we will be having a breathing head. head will, instead of having null in the head, by virtue of this line we will be having 333 in the head now, right? So this is how a node is added in the linked list. But if you see, a linked list can have many nodes. For example, this is another node and this is another node, for example, and I want to make a new node. If you see here, this blue one is the new node. Now this new node is not part of the linked list because it is not attached to any node of the linked list. I have multiple choices. For example, I can place this new node here like this. Now this new node is added to the head of the linked list, or I can add this node here at the end, right? Now this new node is added to the tail of the linked list, right? This particular function actually does what? It adds nodes at the head of the linked list, right? But since I have added only one node, so you won't have any good idea of how these nodes are being added to the head of the linked list. So let me do another example where let's assume that this function is called again, and let's assume we pass this function a value of 5, right? Now what will happen, that first of all this line will be executed and it says okay, create new node, and that node should be pointed by ptr new, right? But remember, if when this code gets executed, this node will remain in memory, but this ptr new, this variable will vanish because this was temporary variable or local variable of the function. So otherwise all the rest of the things will remain in memory. Now okay, this one will be better. Okay, now let us execute this function once again, and as I was saying that we will pass this function a value of 5, and what will happen, this line will be executed. It says okay, create new ptr, okay, create new ptr. So what will happen is that a new node, rather let me make it like this, a new node will be created, right? This new node is created and it will have of course 2 fields, right? And it will have some address as well. Let's assume its address is 666, right? Now this all this will happen by executing this line, and if you see the next line, it says okay, this node, okay, let me name it as well, ptr new, this is ptr new, and it says okay, ptr new, in the data field of ptr new place the value. Okay, right. Now what will happen here, our value was 5. Now the next thing is important. What it says in the next field of ptr new place the head ptr, right? If you see here, the head ptr value is 333. Now what will happen, now in the next field we will have 333 excuse me, and by placing 333 here, what will happen is that these two things will be connected, right? Now this node will be connected to this 333 node, and then if you see here, now this one is the has become the head of the, previously this node was head because we had only one node. Now this node should become the head because this node has came before this or in front of the previously existing node. So by virtue of this line here, it says that now update the head ptr, and now list head ptr is equal to ptr new. Now if you see, ptr new address is 666, so here the head should, instead of having 333 as a head, we will have 666 as the head. Now this one will become the head. Okay, right? And then let me update it. Head is equal to 666, right? So this is how this add new node function works. Let us add yet another node. Let's assume this time the value which we will be passing is, let's say 9. Okay, now we create a new we pass this value 9 to this function. What will happen, this line will execute, it will create a new node, like for example like this. Okay, let me draw it like this, right? This new node is created, and this node has two fields, right, data and next field. Now by virtue of this line, okay, let me write here as ptr new, and we have to give address to this particular node as well. For example, its address is 888, right? Now ptr new data is equal to value. So the value which I forgot that value, I think that was 9. We will be placing this 9 using this line. Using this line we will be placing 9 here, right? And it says in the next field of this new ptr place head. If you see head here, the value of head is 666, right? So in the next field we will be having 666, right? So by using this line, these two nodes will be connected. If you see here, these two nodes get connected, and now using the last line we have to update this head as well, because now this person is the new head, which is address of which is stored in ptr new. So we will remove this and we will make it like this using this line. So head ptr is equal to new ptr, so we have to update it as well. Okay, let me update it. Head is equal to 888, right? So this is how this add new add node at head function works, right? So I hope it is clear to you. Now let us move to the next function which we have. The next function basically does what? It actually adds node at the tail, right? It adds node. This one was adding node at head, but this function adds node at the tail. So let us use the same example. Okay, right? I will be pasting the add node at tail function here. So let me remove this code. Let me copy this code from here and let us paste it here. I hope it works. Yes, it is working. Okay, now this is the new code which will add node at tail. Okay, now here if you see the linked list, this is already created linked list, and if you want to reach at the tail of the linked list, which is the last node of the linked list, okay, if you see this visually here, you know that okay, this one is the tail, but the compiler or computer, the C++ code does not see the linked list visually. So which pointer this code will have access to? It will have access to this head pointer. It will see, okay, this head of this linked list is placed at location 888, right? Now if you see these three nodes, which property of this node tells you that this particular node is a tail node, right? If you see here, the tail node will always have null in its next field, right? So the strategy what we will be using here is that we will be going to the head node first, and in the head node we will see if the next node has null. Okay, this next node does not have null, and we know the address of the next node. We know that it's 666, so we will go to the location 666. In the 666 location we will see, okay, if the next pointer has null, okay, next pointer does not have null, so we will be going to this 333 location, and we will come here and we will see, okay, this next pointer in this 333 location, the next pointer has got null, so it means that this node is the tail node, right? So this is how we will be working in this particular code. Now going through this code line by line, if you see here, we have created a node, a new ptr. It will create a new node. Now this piece of code does what? It will create a new node for you. That's all, and it will be like ptr new, and there will be some address. Let's say the address is 222. That's all. This node will be created. Nothing is inserted into these cells, and this node is not attached to this linked list as well. So this piece of code will just be doing this task, right? And then if you see Next, there is a temporary pointer which is initialized to head, right? This one. So there a temporary pointer will be initialized. It will be pointing to the head of the linked list, right? Now, okay, let me execute this code. Let's assume we pass a value of, let's say, 14 to this function. So what will happen? A new node will be created, and now that's all. This line will simply create this thing, right? That's all. Now this piece of code will does what? It will create a temporary pointer temp, which will be initialized to head, which is what 888, right? So it is simply going to point to this location, right? Now if you see the next piece of code here, it says, okay, I forgot to write here, let me write it now. ptr new and let us give it some address. Let's say 222 I have not used earlier, so 222 is the address of this particular node. Now what it says that, okay, ptr new data in the data field of this ptr new, place the value, and the value which we thought we will be placing is like 14, and it says that in the next field of this ptr new, place null. Since we know that we will be adding this node to the end of the linked list, and the last node always contains null in the next field, so that is why we are placing null here. Now, so far what we have done using these three lines, we have simply created a node. We have simply created this new node, but this node is not attached to this linked list. The next task is to attach this node to the linked list, right? Now, if you see here, this is a if statement, and I am skipping it. Right, because I will be demonstrating the use of this if statement using another example shortly. So that is why temporarily I am skipping it. Now if you see here, this while statement, it says that while ptr temp, the place where ptr temp is pointing and the next field is not equal to null, right? If you see here, this ptr temp is pointing to a 888 location and the next field does not has null. So what it says, okay, ptr temp is equal to, right, this value should be removed, and this value should be ptr temp, the place where ptr temp is pointing, and the next field, right? So what will happen here, that when we execute these two lines, what will happen, it will say, okay, ptr temp is pointing here, and here this next field is not null. So what you do, you remove this 888, this 666 is written here, this 666 will come here, and instead of ptr temp pointing here, it will be pointing to this location, right? Now this while statement will be executed again, and what it says, that the location where this temp is pointing, this one is 666 location, at this complete location the next field is not null. Okay, it is not null. Okay, then what you do, they remove this 666, pick this value 333, this 333 value will be available here, and now this pointer is pointing here, right? Now if we reach here, and here in the next field there is null, so this statement gets untrue or false. So this while loop terminates here, and if you see the last line, this one is important. What it says that the temp ptr next, now this value should be changed. It says place here, instead of null, place here what, ptr new. If you see here, ptr new is 222. Now here, okay, I don't have space here, I will be writing 222 here. Now this 222 will be placed in this next field, and in this way this node get connected to this new node, right? So this is how this new node is added to the tail of the linked list, right? Okay, now let me draw the final shape. Final shape will be like this. Finally this temp will be pointing to 333. Now this will be pointing to, oh, this will be pointing here, right? This temp will be pointing here, and what will happen that this null will be removed, and this null will have address of this new node, that is 222, right? And this way these two, okay, these two nodes will be connected. I am not happy with this arrow. Let me draw it again. Okay, it is not getting drawn. I am not going to leave it. Okay, now this is how this complete linked list gets connected, and the node gets added at the tail. I'm not going to add another node because of you, since this is a video lecture, you can always go back and run the whole scenario, and you will be having the idea that how it is working, right? But now this was a scenario where the linked list was already available there. We already had nodes, and we went to the tail of the linked list to add the new node. But there can be a scenario when the first node which is being created becomes the tail node. For example, okay, for example, there can be a scenario that there is no node, right? Okay, for example, there is no node, there is no, this node is not there, okay. Clear all, no, don't clear all. For example, this node is not there, this is not there, this is not there, this is not there, this is not there, nothing is there. Now, okay, so if nothing is there, then what will be happening here is that the head will be null, right? Now under this scenario, let us execute this piece of code which adds a node at the tail. Now what will happen that by virtue of this line, by virtue of this particular line, a new node will be created. And okay, and this new PTR, let's say PTR new, and let's assume it has the address 333, right? And PTR new data field, it says okay, put value in the data field of PTR new. Let's assume that the value is 52, right? And it says PTR new next field should be null, okay, right? Now here this node is created, but it is not attached to the linked list. Again, the linked list is initially null, there is no node, but in any case this node is not part of the list, right? Now if you see the next line which I skipped last time, was for such scenario. It says if head is null, okay, the head is null. Now what will it do? It will simply make the head equal to this new PTR, that is 333. Now this new node becomes the head of the linked list, that's all. No need to go any further in the code. Now this piece of code will be skipped. It will be returning this to the main function immediately after this, because this new node, which is the only node, also becomes the tail of the linked list, and it is obviously the head of the linked list as well, right? So today we covered these two functions, add node at head and add node at tail. In the next lecture we will be covering this display list. It's a simpler code, but and this display specific node, basically searching in the linked list, but this one is a bit challenging, but hopefully I'll be able to make you understand. Delete a specific node. So we will be covering these three things in the next lecture.